late for your class.
That'd be bad.
And you kept it kept reoccurring. Like I'd wake up, go back to sleep, and it happened again.
That's why you were first one here, Ellen.
You saw me?
Yeah, saw you.
I thought you drove the bus.
No, I mean, in my class. You
Oh,
got in here
oh,
early today.
Yeah.
Okay, so we'll go through this one real quick. It looks like both groups are kind of there, so as soon as my marker wakes up, come on, marker. Alright, so first thing I'm going to do here on this, and they didn't give me a humongo graph, but I can make it work. I'm going to go find my x -2 line. 1, 2, and y'all did that. Remember, you don't have to make that dotted line, but it just helps me. So I like seeing that y'all are doing that. Okay, now both of these equations that you're going to graph are already in slope-intercept form, so you don't have to worry a lot about them. I got aggravated at some of the classes yesterday. They don't remember how to graph slope-intercept form, and y'all have been doing that since middle school. So remember, this is mx plus b, so you always start with your b, so it's a -5. So I'm going to go down 5. 1, 2, 3, 4, 5. And then its slope is -3. So that's understood over 1, so I can go down 3 and right 1, or I could go up 3 and left 1. Okay, so I got 3 little dots there that I see I can connect to make a line, but look here at the rule for that line. It wants me to only show the part of it that's to the left of my dotted line. That's what less than means, right? So let me continue this dot here. Let me go up 3 more. And to the left 1, and there it would have hit, I just lost it. 1, 2, 3, 1. There it would hit my line, but it needs to have an open circle on that one, right? Because it doesn't have the bar underneath it. Y'all remember that? So then 1, 2, 3, 1. So I can connect there through that. Shazam. Okay, we got that on both of them. Looks pretty good. Everybody okay with that? Oh man.
It was about
My new dance moves? Oh, just kidding.
yeah, but it was.
She said, yeah.
Oh.
Oh,
Wait.
okay.
Yeah.
Just kidding.
If I remember, I'll ask you.
All right. So you don't have to do this, but I am. I'm going to go ahead and erase those other dots that don't count because they didn't meet my rule. Now my second line here, it's got a y-intercept of 1. So back to the origin, up 1 and put a dot. And then its slope is -1, because that -x means -1x. So I could go down 1 and right 1, or I could go up 1 and left 1. But let's see which side this wants. Greater than -2, so it wants the right side, which is where I am. So let me take this top dot I wrote and do a 1, 1 slope one more time, and that one will get colored in because it's got the bar underneath it. Get something looking kind of like that.
Wait.
Yeah. What? Wait. What? Okay. We need to discuss the domain and the range. Yeah. So what do we got on the domain? Does it go? This is what the question how I worded it to Jalen, and this will answer your domain every time. Does it go forever to the left? Yes. Does it go forever to the right? Yes. Is at least one of your circles colored in on the dotted line? Yes. So that gets it all real numbers. Now, we didn't have a range like this one yesterday, but the range, does it go forever up?
Yeah.
Yes. Does it go forever down?
No.
Yes.
Wait, where? Which one?
This one?
Oh, yeah.
Yep. So its range is also all real numbers. Because even you could say, well, it's not touching it right there, and that's true on that line, but the other line would hit that point. Okay? All right, so ready to go to some absolute value functions now. Everybody got what you need for our circle erase? Hey, hey, hey! Yes, ma'am? Well, remember, it's up and down. So if it's up and down and your dotted line's over here, but it's still up and down over here, that still hits it. That's confusing to think about. But like, so this line right here that you graphed is gonna keep going down forever. So even though this one didn't touch it, on the same Y value, this one did. Because this is the same Y value. That's all you're worried about in range is the Y value. Does that kind of make a little sense? Alright. Okay, let's look at some absolute value graphs. Now, here's one thing that we need to know, and we're going to go through this probably next week. It might be the end of this week. I don't remember for sure what the plan says. But we're going to make sure we understand what's called parent functions, meaning what all the basic different graphs that we're going to learn should look like. So an absolute value graph is going to look like a V. It's going to have a point at the vertex, and it's either going to be a real sharp V going up or a real sharp V upside down going down. So that's what we're going to be graphing today are these V's, these absolute value functions. We get our new paper. I think I already got a graph page ready. Yes, I do. Hippity-hoo. Woo! All right. So let's say we want to graph f of x is equal to the absolute value of x minus 4. Okay? So just write the function down and we're going to go through the steps together. F of x equals the absolute value of x minus 4, and we know just because I just told you this is going to make a v. Alright, so step 1, we want to find the x value of the vertex, so where that point of the v is going to be. So to do that, to find the x value of the vertex, you take what's inside the bars, set it equal to 0, and solve. Okay, so we know we move over 4 from the origin, 1, 2, 3, 4, somewhere on that line is where the point of my v is going to be. Alright, that's what we found. So the reason we need to define that is because in order to graph it, we're going to make an old school input-output table. Now think about it, think about what you know about vertex. Where would the vertex be on our V? That was a lot of letters I just said, B on our V. How could I describe to somebody that doesn't know what vertex means where the vertex would be located on a shape? It'd be kind of in the middle, right? So I want to put that x coordinate 4 right here in the middle, and then I'm just going to pick some on both sides of it. So I got a 4, so I can go 3, 2, 1, 5, 6, 7. Now all you're going to do is plug those in and solve. Okay, so plug my 1 in, 1 minus 4. We're going to do, these are easy, we're going to do this mentally. 1 minus 4 is negative 3. Absolute value of negative 3 is 3. Good job. Okay, see what we're doing? Okay, 2 minus 4 is negative 2. Absolute value of negative 2 is 2. We okay? Plug my 3 in. 3 minus 4 is negative 1. Absolute value of negative 1 is 1. Now here's where my vertex is going to be. Plug my 4 in. 4 minus 4 is 0. Absolute value is 0. Now think about this. Just try to be looking ahead to make sure all this stuff is making sense. I told you, might not have known, but I told you our graphs are going to make either a V or an upside down V, right? So if that vertex is at 4, 0, on whichever one of these it is, what do you think is going to start happening right here? So it's probably going to be repeats, isn't it? Because it would be, these would be like mirror images, right? Okay, so let's see, plug a 5 in. 5 minus 4 is 1, absolute value of 1 is 1. And look, does that kind of make a little bit of sense to you? Pretty cool how that works out. Whoop, whoop, whoop. 5 minus 4 is 1, absolute value of 1 is 1. We'll throw that there. 6 minus 4, I'm plugging the 6 in. 6 minus 4 is 2, absolute value of 2 is 2. See how the pattern's going there? 7 minus 4 is 3, absolute value of 3 is 3. So there we've got our points to plot. We're going to plot those and then we'll be able to draw our V. So remember x, go from the origin over 1 up 3. So I'm over 1 up 3. Bada bing, bada boom. over 2, up 2, back to the origin, over 2, up 2, y'all got y'all's rocking, over 3, up 1, over 4, up 0, over 5, up 1,
Did,
I'm listening,
did you go over 1 up 3?
over 1, up 1, 2, 3, yep. Then I got my last one over 7, up 3. So all I got left to do is draw my V.
Will we find the name of
Mm-hmm. You all on it. Okay, so what we know already, you're gonna be asked, and you now can say that the vertex of that dude, that's right there at that center point, is 4, 0. So now let's also label our domain and our range. Alright, so domain, go ahead. Oh, I thought you was going to talk to me, Jayla.
Is it the same one where you have to do every X?
Mm-hmm.
Okay. So I just feel like 1, 2, 3.
No, I didn't know that's what you meant, I'm sorry, that's my fault, no. We just plugged those into the table, but could I plug more in?
Yeah.
Right, cause this thing's gonna keep going to the right forever. Right? Is it gonna keep going to the left forever? Yes, so what's our domain? You got it, all real numbers. Okay, range is up and down, it's your Y. Is it gonna go up forever? So it's gonna be reaching positive infinity possibly. Is it gonna go down forever? No, what's the lowest Y value it's gonna touch?
4, 0.
0 on the Y,
Zero.
on the Y. So I could say my range Y has to be greater than or equal to 0. I could also, if I wanted to use infinity, say it goes from 0 to infinity. Either one of those would be good. Pretty easy, isn't it? Yeah, these are easier for me to see than those. Makes more sense when they're hooked together. Good. Did you think of your question on yet?
No.
Oh,
I
man.
lost it.
What you got? Alright, let's look at another one. I'm gonna start you with it. I don't wanna leave you alone yet. I'm gonna start you with it, and then you're gonna finish it just at your tables. Come on, paper. There you go. You're slow today like me. F of x equals the absolute value of 2x plus 6. The directions say to graph the function, tell the vertex, the domain, and the range. So all the things that we just did. So how did we start the last one? What did we find first? Our x of the vertex. Very good, Kinley. How do we find our x of the vertex? So what's inside the bars, only because in a little bit, or in the coming days, we might have more stuff happening. So only what's inside the bars, set that equal to 0 and solve. Okay. Shouldn't be hard for you to get that solved, right? So when we go to make our input-output table, what we know is that -3 is going to be in about the middle, because that's your vertex. So we want to add some x's on the left side of it. So I could say -4, -5. I'm just going to shorten it up some this time. And then add some x's on the right side of it. -2, -1. Now, could I put like 5, 6, or 7 if I wanted to? Yeah, that'd just make, you would just be extending your V way on out there, and that's fine. It'll work. Alright, so let's plug those dudes in. I think you can probably still do this mentally. We're pretty good at that. So -5, right here. 2 times -5 is -10. -10 plus 6 is -4. Absolute value of -4 is 4. Winner. 2 times -4 is -8. -8 plus 6 is negative 2. Absolute value of negative 2 is 2. Alright, negative 3 is my next one. 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. Absolute value of 0 is 0. Now, if you were a gambler, I guess is a better word, what would you gamble to be the next number right here? 2, because it's going to mirror that. Very good. Negative 2 times 2 is negative 4. Negative 4 plus 6 is 2. Absolute value of 2 is 2. Good job, Jalen. My last one should be a 4 unless I screw up. 2 times negative 1 is negative 2. Negative 2 plus 6 is 4. Absolute value of 4 is 4. You got everything you need to draw your V. So, I need to go left 5 and up 4. 1, 2, 3, 4, 5. 1, 2, 3, 4.
What? Oh.
And then left 4. Up 2. And then left 3. Up 0. Left 2. Up 2. This one looks to be more narrow, doesn't it? It's skinnier. It's been on a diet. 4. And you got it, sisters and brothers. I'm the best V drawer around. I wish I could draw a V that straight. Oh, wait, I cheated. Cheater. Oh, I was going to let y'all do that, and I just had so much fun I kept going. Sorry. We know the vertex now. What was the vertex? Negative 3, 0. Pretty straightforward for your domain. All real numbers. Range. Remember, range has to do with y's.
Something infinity.
It could be, let's write it the other way.
0 to infinity, or y is greater than or equal to 0.
Very good. Either one of those would work, like Kinley and Austin said, from 0 to infinity, or y is greater than or equal to 0. Very good, very good, very good. If you're gonna tell jokes, you gotta tell me too.
No.
You feel like cracking up and I feel left out.
I'm doing it.
It's just a little bit missing.
The negative 3 is supposed to be 0. Okay. What's supposed to be on the 4 is 4, 2, 0, 2, 4. There you go.
Good thing y'all are working it out over there. Okay, so I talked about when stuff was outside. So let's do one where we got stuff outside. Fabulous idea. Well, thanks. That's why I get paid the big bucks.
What was the range on that?
Graded y is greater than or equal to 0. White paper is boring. Nice orange paper. That would be cool. Let me just see if I can do orange papers. Okay, so this one says f of x equals the absolute value of x plus 5. So I gave you some extra stuff out there. But we're still going to do everything the same way. So we're still going to start by, like Kimberly so well said last time, finding the x of the vertex. And we find the x of the vertex. That's like a rhyme. We can make a rap. Find the x of the vertex. By setting what's inside the bars equal to 0 and solving. Whoa. That's a hard one to solve.
Wait, why'd you do that? Why'd you do that?
That was funny, Kinley. Because to find the x of the vertex, you take what's inside the bars and set it equal to 0. Well, inside the bars, we've only got an x.
Oh, okay.
So see, that's too easy, it confused you. Okay? So, and me and Leilani did not laugh. 0 would be in the middle, right? Pick a few points to the left of 0. How about -1 and -2, and I'm gonna be overachiever and do -3. Now, let's pick a few numbers to the right of 0, so I'm gonna stick with 1, 2, and 3. Now, do you have to make it nice and pretty with 0 in the middle every time?
Yes.
No. It make it more difficult for you to graph and more difficult for you to see where the point of your vertex is, but it's not necessary. I recommend it, but it's not necessary. Okay, so when we plug these in now, I got an absolute value of -3, which is 3, and then +5, right?
So 8.
Uh-huh. Absolute value of -2 is 2, +5. Uh-huh. Absolute value of -1 is 1, +5. Yeah, you're right, they're just going down. 0 +5. But now what's gonna happen with my 1? You got it, Kira? 1 +5, we start going back up. She said, it's gonna go. Yeah, you got it. 2 +5 and 3 +5. Okay, so far the ones that we've graphed, the vertex has set on the origin. Does this vertex sit on the origin? No, because look right here, remember 0, our vertex is at 0, 5. So it's going to be way up there. So we've shifted it up. I wondered, would that have anything to do with this big +5 stuck on the end? Why, yes, it does. And we're going to be learning about that this unit. So y'all are already making good inferences. Isn't that an English word? Left 3, up 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. What you racing for? We just started.
I know, I didn't make my thing long enough.
Rookie mistake. Just kidding, I do that all the time. And I'm not a rookie. I'm an old fogey.
She's a victim.
Did you watch those games last night, Hunter? They were crazy. Oh, I had the Braves game on my computer during parent-teacher conferences. Don't tell anyone. And I left thinking the Braves were going to win easy. Oh no, Dodgers came back in the ninth inning and hit a home run to tie it, and then went on to win. Then I fell asleep thinking that the Red Sox were going to win again. Woke up to find out that the Astros scored like 7 in the ninth inning to come back and win. It's crazy.
I like when new teams win.
I do too. I feel like I missed 1, 2. And a lot of people are hating on the Astros because they were cheaters, but I still like the Astros. I mean, they did cheat, but they got caught. They're over that. Be fun if it were the Braves and the Astros, be 2 southern type teams, not the big money markets.
Yep. The Dodgers are real good.
Yep, Dodgers and Red Sox both got the money. I bet my boots that y'all all know the domain on this one because it's going to go to the right forever and it's going to go to the left forever. So, I almost called you Kenny G, but Kinley, the domain would be all real numbers. Right?
Are you talking to me?
Uh-huh. I'm just making up names for you.
Oh, yeah.
Okay? Now, the range is going to be, it's not going to be greater than or equal to 0 this time because it's not sitting on 0. What's it sitting on?
5.
So it's going to be greater than or equal to 5. Now, we will see these eventually. We're not going to today because we're on a short period and don't have a plethora, I'm using big words today, don't have a plethora of time. But we will see these where they're upside down like that one I drew over there. When they're upside down, then it would be on your range less than or equal to, right? Because they'd be going down forever. That's a thought to ponder.
On these, will the donut always be on?
The only time they won't be, and we won't learn about this for a while, is when the V rotates. Yeah. But we're not ready for any rotating V's yet. It does. Yes, my range, yes. Okay, last one I want to look at with you is an inequality, because those all had equal signs. And you know what happens when we have an inequality sign? I get to color. Remember my scribbles? Shading? Oh, I thought that would bring more excitement. Let me see if I can get a graph paper will show up on orange. This is going to be so exciting, and it does. I won't be able don't know. What do you think?
The red is fine.
The red's gone.
Well, I'll make it have little numbers so I don't need the red. Let's get a white marker. I love some orange.
Might be able to change like the background of yellow.
Oh, but I want an orange. Orange is my favorite.
Orange is your favorite color?
Okay, so this is the exact same stuff that we've been doing, except instead of y equals, this says y is less than. So we're still gonna have a v, but then we're gonna have to do our checkpoint, figure out where to shade.
Is it F over F?
F of x is the same as y, yes, yes, yes.
So like, do I need to put the what?
It doesn't matter. You need to know that they're interchangeable. So it doesn't matter which way you write it, just know it's the same thing. Alright, so we're going to start the same as we have. We're going to take what's inside the bars and set it equal to 0 and solve. By now that should be pretty easy for you to do. So you get a -1. Right? So that's going to be where our vertex is. So I'm going to put that in the middle. I can't draw that line straight to save my life. And then I'll go to the left of it. And then I'll go to the right of it. Okay? Now we're going to plug those numbers in. Just do it real quick. -3 plus 1 is -2. Absolute value of -2 is 2. -2 plus 1 is -1. Absolute value of -1 is 1. You okay? -1 plus 1 is 0. Absolute value of 0 is 0.
Wait,
Yes.
you forgot. Or was that for 0 or 1? -1, I mean, the 0.
Oh, you're right. That 0 needs to go by -1. You are right. I've dropped that down. Thank you. That saved me a big blunder. Kenley is on her game today. Thank you. 0 plus 1 is 1. Absolute value of 1 is 1. And then 1 plus 1 is 2. Absolute value of 2 is 2. Now go ahead and plot them, but don't connect them yet. Because we're going to have to talk about how to connect them. Remember that? So... Oh, Austin, I'm not going to be able to do this next period because look, that first blue line is really just like a half away. I'm going to pretend it's a whole and go with it, but that's not good. See how that's shorter than this? Alright, so 1, 2, 3, 1, 2. 1, 2, 1.
Oh, wow.
-1, 0. 0. 1, see, that's making my thing be skewed. 1, 1, 2. Well, not horribly. Okay, I was so excited about orange paper that really messed this one up. But, anyway, I've told you not to connect them yet because remember when we got an inequality, it could be either dashed or solid line.
This does not look right.
Well, mine doesn't look right because my spaces aren't even. Yours looks better than mine.
Yeah, but... Oh, okay.
Yours looks better than mine. Alright, so I got less than. It's not less than or equal to, so should my lines to connect this V be solid or dashed? Dashed, you got it. So let me grab a dashed line real quick
Why'd you dash it?
because it doesn't have the equal bar underneath it. Remember that? Boy, I should not do that graph paper. Okay, or not the orange background. Now we got to figure out where to shade. And it's the same as when we did those overlapping scribbles. I would plug in a test point. So I would say my V is not touching 0, 0. So I'm going to plug 0, 0 in, see if it makes it true or not. If it makes it true, that means that point will get colored. So I'll shade everywhere outside the V. If it makes it false, I can't color that part, so I'll shade inside the V. So plug your 0, 0 in. 0 is less than the absolute value of 0 plus 1. 0 plus 1 is 1. Absolute value of 1 is 1. Is 0 less than 1?
Yes.
Yes. And so that means that point right there at 0, 0 made my sentence true, so it gets shaded, and it is outside of the V. So we shade everything outside of the V on both sides.
Did you say that's 0, 0?
Uh-huh. And you can pick any point you want as long as it's not touching your V. Zeros are just easy to compute because there's nothing to them. Haha, that's a funny math joke. There's nothing to a 0. Let that sink in, and you'll get it tomorrow.
Yeah, I don't get it right now.
I was just
Wait, what
teasing
did you,
with
I don't even know what you said.
There's nothing to a zero.
nothing to it, zeros, nothing to it. It's okay, Cameron, I know I'm not funny, I
Nothing.
try to be, but it doesn't work. Okay, so, we could graph a whole lot more of those, but it's really just the same stuff. But what I wanna do is show you, do we got time for me to show you how to do it on your calculator? Yes, grab your graphing calculator. Oh, domain, yes, thank you, Summer. Domain is all real numbers. And then range, it's sitting on 0, so y would have to be greater than or equal to 0. Alright, let me get, I think y'all can see what I'm doing on the calculator better when I use the Elmo than when I use the fancy calculator on my thing, my ladybug. So let me pull my ladybug real fast. No, I thought it was already ready. What happens when it falls asleep, I guess. Okay, so you're gonna graph, we haven't even talked about how to graph a line on these things, but I think you already know how. Anyway, all your graphing buttons are on that top row right underneath the screen. So I wanna hit y equals. Let's see if I can turn the light on that, make it any better. No, well, that's not very cool. Let me just turn the lights off real fast. So I'm gonna hit y equals, and to get, I think I've talked to you about the absolute value bars before. To get the absolute value bars up, you hit math, which is right there underneath the alpha button, hit math. And then move it all the way, or not all the way, move it over 1 to num. And that very first one that says ABS, that's absolute value, so you pick that.
Oh, we're supposed to be in y equals.
Yeah, that's where you'll go to do all your graphing. And now you just type in whatever the equation says. So I'm gonna type in, let me get it underneath here so I can read it. 2x plus 5 inside the bars.
Where's your X button?
The X button is right here underneath mode. It says XT theta.
Oh, yeah.
And then I'm gonna throw a -3 outside the bars. Yeah, let me write it on the board for you. And then once you get that, you'll just hit graph.
And you get a very wide V.
And there I can see my V. Okay, now what's going to be most useful to you anytime you're graphing, did you not get it? Yeah, is your table. Remember how we've been picking our points and making that table? If you'll push the second button and then graph, it's got the table already made for you. You can scroll through there and find any XY coordinate you want. Okay, so pretty handy on that. Alright, so tomorrow, lights are coming on. Tomorrow, I'm going to give you some of these to do on your own. Okay, might have some V's and I might have some of the piecewise that we did yesterday also. Okay, everybody alright? I think you understood better than you did yesterday, it seems like. Would you agree?
Yeah, today
Good.
just seems easy.
Good. Alright.
Just the second one.
Miss Ryan, how much more time do we have left?
About 3 minutes
How did you see
to get second, the blue button. And then graph again, see how it says table of them? There you go. And you can even scroll it up to get up there to the negatives, you can see any of them. Yeah. You're welcome. And to get back out of that, always push second and then mode says quit.
Do you want me to stop recording?
Oh, yeah, I'll get it, thank you. We got some extras today.
Yeah.